Hello students, welcome to my class. So in last class we have discussed about acceleration. So when acceleration takes place, when there is change in velocity of the body, that means when the velocity of the body changes or there is a difference between the initial and final velocity of the body, at that time you can find or you can say that the body is being accelerated. It may be positive acceleration, it may be negative acceleration. So today we will read about acceleration due to gravity. So what is acceleration due to gravity? So we can write that when a body falls freely under the action of gravity, the acceleration produced by the body is known as or is called acceleration due to gravity. It means we know that everybody is being attracted by the gravity or force of gravity or by the earth towards its center. So when we drop a body from a certain height, it will be attracted by the gravity and it will fall freely under the action of gravity. At that time, how much acceleration will be produced by the body, that is equal to the acceleration due to gravity. Or we may say that the acceleration produced by a freely falling body is also known as the acceleration due to gravity, and it is denoted as g, small g, and its average value on earth is 9.8 meter per second square. 9.8 meter per second square, the average value of the acceleration due to gravity on the surface of earth. The details about acceleration due to gravity you will read in the gravitational chapter or gravitation chapter. So only what is needed in this chapter or for this chapter I have told you that. In gravitation chapter you will read more on acceleration due to gravity. Clear? Now we will read about graphical representation of motion. Graphical representation of motion. It means we will represent the motion of a body by certain graphs. You may know what is graph. There is a x-axis, there is a y-axis. The point of intersection between x-axis and y-axis will be origin. So we will not go to the mathematics. We will just see how the motion of a body be represented by the help of a graph. So there are three types of graph. So first is speed or velocity time graph. Number 2, distance or displacement time graph. And number 3, acceleration time graph. The first 2 graphs we will read. The third graph we will read in class 11 and 12. So first graph we will read about the distance or displacement time graph. We will just take distance, not displacement. We will take the distance time graph. So first of all, distance time graph of a body at rest. So when a body will be at rest, it will not change its position. It will not change its position means it will not travel any distance. That means if we take a point of reference, from the point of reference, every time the distance will be same. So let us take a graph, 2 axes. One is, this is the distance s, and this axis is time t. Or this axis will be distance, we will take, this axis will be time. This is the point origin. Suppose initially at time t, the body is at s distance from the point of observation or point of watching. As the body is at rest, the body will not change its position. That means as the time will go on, the body after 1 second body will be here, after 2 second body will be here, after 3 second body will be here, after 4 second body will be here. If we join these lines, we will find a straight line which will be parallel to the time axis. So this is the distance time graph. Suppose this is A, this is B. This AB is the distance time graph of a body at rest which is parallel to the time axis, because as the time will go, the distance remains same. Next we will see same thing, distance time graph of a body moving with uniform speed. I have told you uniform speed. In uniform speed, equal distance will be travelled in equal interval of time. So let us take, this is the time, this is the distance. Suppose in this is the point of observation, or we can say origin. Suppose at 1 second the body goes 2 meter. Next second the body goes next 2 meter. Next second the body goes next 2 meter. That means in each second the body goes 2 meter. Now see here, this in 1 second this 2 meter. So graph will be here. This graph will be here. And this graph will be here. If I join here this, it will be a straight line passing through the origin. So this is O, this is A. This O is the velocity, distance time graph of a body moving with uniform velocity. Now, this, what do we get from the graph? The slope of this graph gives speed or velocity of the body. That means if we draw a distance time graph or displacement time graph and we find the slope of the body, slope of the graph, then we can know, or you can find the distance, the velocity or speed of the body. Now my point is, how can we find the slope, or what is the slope? Is any word slope? The slope means inclination. That means how much it is inclined. Now how can we find how much it is inclined? We cannot use the protractor here. So how can we find? Now this is very simple way. How? Just see here. Take any 2 points. This is one point. This is suppose point X. This is point Y. Take 2 points. Draw a horizontal line here. And draw a vertical line one horizontal line. One vertical line, one horizontal line. Now see here. This is the distance. You can measure. This is the time. You can measure. So distance by time is the speed. Clear? So we can find the slope of the body, slope of the graph by this method. Another thing, if we don't want to take 2 points, just take 1 point. This 1 point. Total draw a vertical line here. This distance you measure time. This distance is distance. Distance by time will be speed of the body. Clear? Next. Next we'll see distance time graph of a body moving with non-uniform speed. Or non-uniform motion. Nothing. You will just draw. This is the time. This is the distance. Any type of graph you draw. A curved line or a zigzag line. That will show the distance time graph of a body moving with non-uniform speed. Next we'll go to another graph that is called speed time graph. Speed time graph of a body at rest. Speed time graph of a body at rest. So we'll take the graph, do the graph here. This is the time, this is the speed. Speed V. Now see here. When the body is at rest, can we find the speed of the body? No. So in this case, we cannot draw the speed time graph, but we may draw the velocity time graph. We will read in next class or higher classes. So next graph will read speed time graph of a body moving with uniform speed. Moving with uniform speed. Uniform speed means same speed. Suppose at time 0 the speed is 5 meters per second. Time 1 the speed is 5 meters per second. Time 2 the speed is 5 meters per second. Every time speed will be same. So if I'll join these points, it will be a straight line parallel to the time axis. Suppose this is x, this is y. This xy is the graph, that is the speed time graph of a body moving with uniform speed, which will be parallel to the time axis. Now, what we can get from this graph? If I'll join here, it is a rectangle, and if we find the area of this rectangle or area covered by the speed time graph, we can find the distance covered by the body. That means the area bounded by speed time graph gives distance covered by the body. Is it clear? Next we'll see the speed time graph of a body moving with uniform acceleration. That means the body will have some acceleration here. That means the body speed or velocity will increase. This is the time, this is the speed or velocity. Suppose at the first second body is going 2 meter, next second body is going 4 meter, next second body traveling 2 meter per second. This is 4 meter per second, 6 meter per second. If I'll join this all or plot the points, I'll find there is a straight line passing through the origin. This is this velocity time graph or speed time graph of a body moving with uniform acceleration. Now, if I'll join here with a vertical line, it is a triangle. The area bounded by this triangle, by this graph, can give us the distance covered by the body. And if we find the slope here, like the speed distance time graph, the slope of a speed time graph speed or velocity time graph gives acceleration of body. If we find the slope of the body, slope of the graph, slope of the speed or velocity time graph, we can find the acceleration of body. Now, students get confused in one question. The question is like this: a body covers or body travels with a constant speed or constant velocity of 2 meter per second for 10 seconds. Find its acceleration. Maximum students, they know the formula of acceleration. Acceleration is equal to velocity by time. This is 2 by 10. They do, but actually it is wrong, because acceleration happens when the body increases its velocity. The velocity of the body increased. Here the velocity remains constant. As the velocity remains constant, there is no increase or no decrease of velocity or no change of velocity. As a result, there will be no acceleration. Is it clear? So I think up to this it is clear to you. In the next class we will read the equations of motion, which will be explained or which will be solved by this graph, relating this graph or graphical method. So thank you everyone.